Hello, good afternoon, and welcome back, everyone. So yesterday we learned about the automatic segmentation and all the tools in automatic panel on the project workroom. Today we will focus on segmentation editor that we're gonna show you right now. So this editor you're gonna do mostly manual segmentation, so you can do some manual annotation and also the principle of watershed segmentation. Let's go to Avizo software and we just start the software like this. Just load the data. So you can either go to open data from anywhere and locate the file. So it's on data folder. And again, we're gonna use the same tutorials example from chocolate bar here. So I think you're already familiar how to load this chocolate bar already. Okay, now I'm in the project workroom and we are going to switch to the segmentation workroom, the next tab. But before we go in there, you just take a quick look here. I just load the data. That's just only the data, plain, nothing. And once you click on segmentation workroom here, they will create a label field. But this label field is still empty because we didn't assign any material into the label field. So just take a look. So if I click on segmentation, and you can see this. Just a quick reminder that in your version, probably when you click to the segmentation, you will have pop-up screen saying that there's new segmentation plus workroom, or you want to stay on the classic segmentation workroom. For the time being, we will stay at the classic segmentation workroom, and then later we will go on the new segmentation plus editor. So just stick with the classic segmentation workroom. If you already click to use the new segmentation plus workroom, you can always switch back between the two, the classic and the segmentation plus. Just go to Window, and under the segmentation editor here, you can see that switch to segmentation plus workroom. For example, I click to segmentation plus, it look like this. But today we will stay on the classic segmentation. So again, go back to Window and select switch to classic segmentation workroom. Stay with classic segmentation workroom. So once I come to this segmentation workroom, so this is the interface. So we have segmentation editor, some display, and the viewer over here. And you can see that we have loaded image chocolate bar over here. And underneath them, there's going to be label field that I just mentioned. And this label field is already created. It's called chocolate bar labels. So this label where you're going to create the binary image or binary mask and assign this material to this label field. Before we go further, I'll switch back to project workroom quickly just to show you. So now, if you remember when I load chocolate bar, there's nothing here, but once you switch to segmentation workroom, this label field over here down on the dataset is attached to the dataset. But if you look on the property part of the label field, it's still empty. There's nothing in there because there's no material there. So that's why we need to start to assign the pixel or voxel of the image into this label field. And this assigned voxel we call material. So it depends on how many material you would like to assign to this label field. So remember now it's still empty, 0, 0, and then I go back. So this label field I mentioned, again, you can also create new label field as many as you wish. So if I create the next one, it's gonna be the second label field, and it depends on how many material you want to assign to each label. You can also delete them or rename them. So if I rename this label 2 to just 2, or can just delete this, the second label field. So I have only one label field left anyway. Okay, then the next section is materials. So this is how you're gonna assign the pixel inside of this image here into these materials. So roughly in this image on the right here, you can see that we have at least 3 faces. So very black on the background and have very bright the outer layer of the chocolate and the filling, the mousse. So we know that we're gonna need at least 3 materials to assign all these 3 materials into our container or the label field. So we need to create 2 more materials because by default it already create 1 material here. And as you can see here, they always have this exterior, but the exterior is nothing to do with the label field or the material that we are inside this label field. So just ignore it or disregard it. It's nothing to do with that. It's just something out of our working boundary. So it's something external, exterior, not even background. So since I know that I'm gonna segment 3 phases of the material, so I will add 2 more. So by click on this add, so you can add, for example, 3 more. And I know that I add too much, so I can delete one of this material. So I can maybe delete this one, the material. So now I have material 3, 4, 5. You can also rename them. For example, if I rename this material 3 to background, this, and you can see that before it was red. When you name them with some specific name like background, air, or bone or tissue, there we have the default color. But you can always change the color of your material. For example, I would say the background should be something grayish, like maybe this one. And so I have assigned the gray background to this material. And then this should be chocolate part, or yeah, chocolate. Like this. And let's say I want is to maybe a bit brownish. Let's say over here. Okay. And then material 3, I will rename it mousse. And also you can also rename the color, change the color of the inside. So let's say maybe go to this color. So as you wish to, you can change it to any color you want. As you can see here, in each material that you created, they have option to show them in 3D and 2D. And so you can lock this material not to be working on it, but we will see later, and select the material. You can also, if you delete it, and you can try to locate the new material, but you don't use this that much, mostly add and delete. And below the material section, we have display control. So if you expand the display, you can see that we have 2D and 3D. For 2D, we can adjust the 2D visualization of the panel. And for 3D, so you have to activate the full viewer. I think usually by default, you should get the full viewer, but if not, you can just click on full viewer here. So on the right-hand side is the viewer. So it split it into 4 viewer, including the 3D here. So, but at the moment, we don't have the 3D because we didn't select any object yet. The 3D just to display the 3D selected material. So we will see later. And then you can select to show crosshair or not, and slice or volume of this grayscale image, and adjust this for 3D volume. But this 3D volume rendering is not really useful for segmentation. Just keep in mind. But if you would like to see it, you can also use it. Okay. So just still doing this rendering thing. And then come to the selection part is quite important in segmentation. So we have the tool that you can add or remove the selected materials. And we have this replace. For example, you want to replace one material by another. And also we can erase this selection or clear selection, but not erase. Yeah, everything will be clear when we do some example. And then come to on the right side, we have this viewer. So usually you have 4 viewer, or you can do it 2 viewer, even 1 viewer. But if you stay on 1 viewer, you can click to cycling them between the 4. So from the 3D viewer, X, Y, X, Z, and Y, Z, something like this. So for the beginning, I will stay with 4 viewer, easier. And in each viewer, you can zoom in, zoom out using this magnify tool here. And when you zoom in, you can see that we have this kind of slide bar to move left and right. up and down as well. Or if you zoom out, you can see that there are slides for the slide number. So start from slide number 0 to 294, something like this. It's the same for every slide. You have slide bar and number slide that you can change between the slides in each plane. And you can see that the crosshair will correlate it to your plane. So this XZ is in green, while XY is in red, and the YZ plane is in the crosshair. Okay, now at the bottom of the selection plane, we have this tool that we can use to start to define the pixel or the voxel of the image into your materials. So we start, like by default, is on this arrow tool. So arrow tool, you can interact with all the images. And you have option that you can select all slides or just select all, but usually all slides. And for example, if I select all slides, as you can see here, I click on any images, all the pixel and voxel in this material will be selected like this. So far this is, we call it selected material or selected voxel. We can clear it here. Again, I do selected all slices, and everything will be selected as one global mask. And this is selected voxel can be assigned to each one of your material. For example, I want to assign this to my background because it has been selected already. So I click on background and press this assign button, add a selected material. And now this selected material has been added to background. And at this moment, if you select on 3D, you can see this a 3D of the selected voxel showing in background in this corresponding color. You can also reselect it from this material here by click select. It will select again. And from this selection, you can either assign to different materials. So by default, it's on background, not by default because I added into the background. Now I select it on the selection. You can see this selection, but if you select on something else, which nothing because we didn't add anything to different material yet, nothing in most. So it's only one material, everything added to background. So I want to assign this material to the chocolate. So I just click on chocolate and click this assign here. So now instead of chocolate in background, I already have everything assigned to the chocolate materials. You can also remove this by click select and select here to remove this selected material from your current materials like this. So nothing left anymore. And just don't get confused between the plus and minus sign here and add and delete. So this add just to add a new material, the same delete to delete material. But plus and minus sign here just to assign the selected voxel. So we call selected mask voxel here into individual material that you wish. And the rule is that only one voxel can be assigned to one material. So you cannot assign the same material or the same voxel to different materials. So it could be only in one material only. So okay, let me show you this example. So instead of use select all, I will start using the first tool called brush tool or paint tool here. So I first clear this selection first. So nothing left. And I go to, let's say, on the XY plane, or you can click any plane that you wish for. If I click on XZ, they will activate on the XZ plane. I click now on XY plane, it will activate on XY like this. And you can see that the brush size start to appear here in circle. You can adjust brush size by using the mouse middle wheel to scroll them, and they will increase the size of the mouse, the brush size, or you can just use this slide bar over here to slide the size of the brush. So if I change brush size over here, exactly, you can also change from the circle brush to square brush. Yeah, if you check this, it becomes square brush. Okay. For example, if I want to add this layer like this. So I paint only one slide, and you can see it on the 3D viewer. It's one slide painted. So this is called selected mask voxel or selected voxel. I want to assign this selected voxel into, let's say, assign into chocolate like this. Doesn't matter, it's just example. So now I add it to chocolate. And now you can see that this voxel in this plane had been selected, and it indicates in 2D. You can see the stripe of this color. If I change color to something else, let's say green, let's say, you see the stripe will be according to the color you assign. So I change it to another color to make it easier to see. Something maybe, this one. Okay. So then I want to tell you about it, that only one voxel can be assigned to one material. For example, now I want to do the second paint. So I use the same paint tool over here, and I use the same brush. Let's see if I start to paint like this and go up to have overlapping into the first material like this. And if I assign this second materials to the mousse, you will see that this overlapping between two regions cannot be assigned to two materials because I have only one voxel, one material. So if I assign this to the mousse, you will see that what's going to happen. You can see that what part that used to be the green voxels now it's been reassigned to the mousse material, so it becomes purple. So this is the principle. You can never apply one voxel to two different materials. It has to be one at a time only. Okay, if you're not clear. So then we start to do some real segmentation. So to remove this selected material from each material, for example, I want to go to chocolate bar, chocolate material here. You just click select. Then we select the one that you are highlighted, and you can see here, and you can click here to subtract or delete it. Or even you can assign this selected material that I highlighted right now on the chocolate material. I want to assign them to the mousse material. So when I select it on the chocolate until it's highlighted in red here, then I select the mousse material layer, and then you click again, assign. So now everything will be assigned to one material. So in this way, you can even, for example, you threshold everything and you start to select one layer and assign to different materials. So it would be easier to do this. For example, if I will start doing it like this. I select this and then I delete it. So to remove from my selected material. Okay. So now we want to segment the chocolate bar, the mousse, and the background. So using this principle that one voxel can be assigned only in one material, I'll start with this selected all slice. So I select one here. So now you can see that everything has been selected, and I will assign this selected material, including background, chocolate, and mousse layer, into the background material. This one. And click this plus add sign here to assign this into material background. And now if you can look, you can already assign, or you can just clear selection, not delete, just to clear the view, and you can just look on a 3D. And this is the background that we selected. So everything in this gray, if I can change maybe quickly to other color as well, to maybe a bit yellow like this. And you can see actually the background is more yellow, and it's been painted everything in this yellow stripe. That the 2D viewer. Like you can also hide the 2D viewer as well, because it can get confusing on the next step. For example, next one, I want to start to assign the chocolate layer into the chocolate materials. So what I will do, I will use, for example, paint tool to paint them, but change to the round brush like this. And it might get confusing when you have this 2D visualization of the background, so you can switch on and switch off. So for this purpose, I just switch off the 2D visualization of the assigned material at the background. So I have only the chocolate bar, sorry, the original image. So next is the chocolate part. This is the brighted outer layer part. I want to start to segment them. Okay, but I also want to try to show you how to use the different tools. So first one is brush tool. So you can adjust the brush size, and you can just, for example, paint them like this. And you can see that I have this thing coming up here. And if you have like enclosing of this layer, you can see it's closing, it's lapping. So you can use the function, press F, it will fill, F for fill. Okay, so and if you would like to kind of erase them some parts, so you press control, and then when you paint, it just remove what you don't need, for example, like this. Okay, one more time. So if you want to clear everything, just select clear, and then I'll start painting again. I will do it roughly, just not too really precise. So I do here, paint like this, and to fill, just press F, fill, and then if you think you overdraw them, you want to correct them, just press control, and you can just erase some part that you don't need, like this. And you can see the representative of the selected voxel by drawing. So this is completely, totally manual. So you just contour line just to draw and then to select this voxel in 2D. And you can see that because I draw in one slide, it's always 2D. And if I go back here and I draw one more time, I also get another 2D. But we have another tool that really useful in terms of how you can create is 3D interpolation of the shape that you created. So it's not very accurate, but I'll just show you. For example, I draw in 3 slides. So from the beginning, in the middle one, and the last one. So we have this object here. And then you go to selection. This is what we are selected. So go to selection on the top. And then they have this to interpolate. You can so interpolate between the 3 slides. So you need at least 2 slides to interpolate. So everything in between will be interpolate. So you can see now, I only draw 2 or 3 slides, and then you just interpolate it. But it's not very accurate in this case. And I think it's not really good to use this brush tool and interpolate them. You can do it, but it is not really very accurate too. So you can clear them. Also, there are something that you can maybe create some fake shape that you want to try something. For example, I can show you quickly. Maybe it's not really useful, but just to give you an idea. So I use the big brush tool here. I stamp one on X, Y, and Y Z. And you can see that they also have the indicator where it appears in the different planes. So I on X, Y, stamp here, and I come to X, Z. So I can make another stamp here. And then the ZY, YZ here, I just stay. And then you can see that I create kind of 3 material in 3 planes overlapping. And what I'm going to show you here, so in selection, you can use wrap tool to wrap around these 3 plane shapes. So you can select wrap. And now object has been wrapped. This is how you can also create like whatever you some tool that you can maybe useful in the future that you can use to fill some gap or create some fake test materials. And then you have this object like this. You can also do further. For example, you can do smooth of all slides. It will be smooth, but you don't see much effect. Or you can do selection, and you can grow volume. Yeah, you can see when I click once, it will keep extending. Grow is also dilation of the pixel. You can see. I hope you see the effect of growing. The same for, you can also shrink them. Volume, and selection, shrink, volume, so it keeps shrinking. And if you're happy with this, then you can assign to any material here. That's just an example. So I clear. So for the real stuff, instead of using mousse or chocolate first, I will start with the mousse first, just to use brush tool to really easily. demonstrate this interpolation capability. So I just use brush tool and maybe on the XY slide. Also important that during the if you would like to use segment interpolation tool, be sure that you stay in one plane at all time, because if you paint on XY like this and then you click on YZ, then the software cannot interpolate anymore because they don't know which direction to interpolate. So you should always stay in one plane when you paint before interpolation, otherwise it confuse and you cannot interpolate. So I clear because I already switched. So I start from, for example, I want to start from the first slide that I can start see the mousse layer here, slide 54. So I use the pen tool, start to precisely draw the border of this mousse layer like this, and F to fill, and you can also press Control to erase some excessive part. Yeah, and then you can look here on the 3D. I'll start to draw the first slide, and then I go to the last slide, only to here. Over here, you can see the last slide, and again do the same drawing. This and F to fill and Control to erase, something like this. So now I have two slides at the beginning, at the end of the mousse layer. Then go to selection, interpolate, and now I get most of the mousse layer inside the filling, and then I will assign this to the mousse material. So select mousse, and then click the plus sign to assign this selected material into this mousse. So click plus, and now you can see that it appear in 2D of the mousse. In the mousse layer, you can go to any layer, you can see all the mousse that's selected. And now you can also go back to the background and select the 2D again to see. You can see before we select everything as a background, but now since we assign only this part to the mousse material, now we have two material in one of this label field. So we have the mousse material in purple and the background in yellow. The next step is the last one. We're going to assign the outer layer of chocolate part to this label field. So I just hide this, for example, for the beginning, for the moment. So now for the red, the chocolate part, instead of using this pen tool, I will just go to the other tool. So let's start with the threshold. So it's number 6. If you press 6, it's a shortcut. So threshold is exactly the same as interactive thresholding that we did yesterday. So if you click on the threshold, number 6, and you have on the bottom that you can select all slides or just only one slide. So, and the first thing you need to do when working with the threshold is that you have to define the threshold region. Just a moment, I need to look. This, yeah, because I was it's been hidden somewhere when I have display control. So I just hide the display control first, and when I hide the display control, you can see that in threshold before I was in pen tool, and then you go to threshold number 6, you start to see this the histogram of the threshold. So you can adjust lower threshold or higher upper threshold. So for example, if you threshold from 0 to 2000, you threshold everything. But since we want to have only the brighter part, so I just only threshold onto this histogram region, very, very bright intensity. So I adjust lower threshold until I see that most of my bright pixel has been selected. And this option you can see is unchecked, all slices. And now if I select mask voxels here, you can see that only one slide has been selected. But if I select all slices, you can also select again, select mask voxel. So everything in this mask will be selected based on this all slide or not. So, okay. And I clear do one more time. So if I uncheck it, only the current slide that you are here will be selected. So I'm on the XY. For example, I go to maybe the first slide, 45. No, maybe this one, slide 54. I select it, but without all slide checked. So I select mask voxel. So I get first slide selected, and I go to the last one that I see my brightest. This one is slide 285, and again select mask voxel. So you can try to do again selection and interpolate, and you can also do interpolate. It's also just to repeat you, or you can just use this function or slide this and then select mask voxel. So this only the brighter chocolate layer has been selected. And once you have this material, now you can assign to this chocolate part, the material thing. So you select the chocolate and then put the plus or the add sign into it. So now you have the chocolate appear here. And if you click all 2D, you can see that the chocolate is, you have to supposed to be green, but because I still on the thresholding, so the mask is still appear. So I have to go to this arrow to hide the mask of the threshold too. So now you can see three region, the background yellow, and the chocolate bar, the chocolate itself, the outer layer is green, and the purple is mousse. So now we have all three materials. And from this, I can go back to project workroom just to show you quickly. So remember when we create the first label field, everything is empty, there's nothing inside. But here we have three materials. So material 0 is the background. I mean, not background, it's the exterior. And then 1, 2, 3. If you remember from yesterday session that I tried to focus on the material number or ID of material. So we have here three material. So material 1 as a background is light blue, and material 2 darker blue is material 2, and material 3 as according to the color map is red. And if you visualize this label image with auto slide, so on the bottom with auto slide, one more time, sorry, auto slide, and press this here, you can see that these three material has been assigned. But if you would like to have the color exactly as you created here, you can do that by like click and label. It's called create label color map. So I don't use this quite often. So you just right click on this label field and then create label color map. Create label color map. So now the color that you see in color watch in auto slides will be linked to this label color map that according to what you assign here. The same for if you want to visualize them in, for example, in 2D volume. So box light rendering. You can also see three of the object, and then if you clip them with auto slide that you created, you can see the object that you created. It's three materials, including background and also outer layer, inner layer. And in this case, for example, you don't need the background. You can just simply delete it. So you can just select and you can completely delete it. But if you delete this background, they will say that this background material will be assigned to exterior, so they will not take into account. That's why they have this exterior part as the trash bin that you can dump anything that you don't need. So I just click on background and select this delete, and they will ask you, are you sure you want to remove this material background? It will be assigned to exterior, so it will not take into account in terms of the segmentation. Okay. And now if I clear, I have only two material left. Now it's only the outer chocolate bar and the mousse inside, and go to project, and I also have only two of the object left because I did remove this from the chocolate bar like this. Is that okay so far with the yes? Yeah. Yes. Yes. Exactly, but before you do segmentation here, you can also apply filter as well. I didn't do the filter because I thought it's a common thing, but you can also always apply filter before the segmentation. So what I did is I just load the chocolate bar quickly. Yeah, no problem. Yeah. Yes, for example, you have the grayscale image here. Oh. So I load chocolate bar here, and I want to have different layers segmented. So I want to have the outer layer of chocolate and the inner layer of the mousse. So you can also use simply thresholding without segmentation workroom. But if you have really difficulty shape, like in electron microscopy, you have to really manually paint it. This is how the manual segmentation come into play, and then you could get something like this. This is kind of manual segmented. You can see that's not perfect, and it can be used like if you want to segment something manually. Yeah. Okay.
Which are the two differences? If I have some complicated case, I use segmentation. If I want to optimize, I use.
Yes, exactly. So this chocolate bar could be really automated really quickly, but if you have like something, no, like some skeleton or some vasculature that you want to do manually tracing, maybe that's the tool that you can do something more control with your hand, and or because sometimes the segmentation, automatic segmentation will not work at all with the thresholding because the signal is too diffuse, is so similar. So, yeah, let's go back to the segmentation workroom. Okay. So that's you already see a few tools, so the brush tool and threshold tool. So maybe I just add one more material background because I deleted. Add here and change maybe color to yellow like this. Okay. So now I will do is I just select everything and I delete it from my material, select this material and also use this to remove this. So I will start from the beginning. So I already show you this threshold tool. So it's like exactly like automatic tool, but also in combination with the segmentation room. We also have similar tool called magic wand. This magic wand here, it how can I say it's yeah, in this example it might not a good idea to show, but they use the same principle of threshold. So you have to create the mask, and then we need region growing. So they will only detect. Okay, maybe this would be the thing. You can see here I set a threshold, and without filter, they have something that are connected and not connected. And then you need just to define the region. For example, I want to use if I go to one region here, if I click here, and you can see that somewhere here they have some connected and not connected region because this something not connected. So if I click one, they only select whatever are connected to each other. And you can see this is the red line is where the center of the intensity, and they only propagate to this in region growing. Or if you just change the intensity more like this, you can see that once it disconnected, the part that's not connected to the main layer will be not selected. But this one is difficult because it will be like this. We are always connected in 3D. So, or if I click here, you can see this. Here, you can see this. This only region only selected because they are connected with the region growing of my intensity where I click it. Because if you zoom in quickly, you can see that where I click, they have this mark here, like you see the little mark, and this mark is here. It is intensity value where I mark, and then they start to grow in this region into the connected voxel that have similar intensity in the range of this lower and upper threshold. Yeah, like this. So you have to define lower and upper threshold, and that's all connected voxel to this region growing will be selected if they are connected and have the intensity in this range. So that's similarity to interactive thresholding. So they use the same threshold, but now they apply region growing, so it becomes magic wand. So imagine if you work on the cells or some kind of image that you want to maybe select different materials in one of image. You have the organelles, mitochondria, vascular. Yes. Yeah.
We have to do separate things.
We can do in one go. Yeah. So you can use this as for we can show you in the next example. You get more understanding of for like multi-material segmentation. But here I just want to show you like the very principle of each tool first, and then we go to more difficult example, because to demonstrate some tool you need some special specific feature to demonstrate it. But this magic wand tool here, you just need to select only the voxel that are in range, in this range, that are range of this region growing signal here. So everything outside will not be selected. That's why when I demonstrate here, if I select this region here, you can see that what I select is turned to purple, red, and blue. And this region growing is over here at a red line. And any voxel that are connected and has to be in this range between lower and upper threshold will be selected. So if I adjust again the kind of lower threshold, you can see that the number of selected to be changed. Like here, before if I just from 0, like everything that are connected will be selected. Okay. For example, here you see I select region growing at this value, so it's marked at red here. And if I set lower threshold like this, and everything that are still connected with lower threshold will be selected. But if I just start to remove the lower threshold, we can see that also with the higher threshold. So it will limit number of voxels to be selected based on this value of the region growing. I hope you see the example right there. But not every here, like not everything selected, even they are connected, because the value of intensity has been outside this threshold value. But this can be clearer with different example, and I will show you later. And yeah, again, for example, this clear quickly. Magic wand, you can also do, for example, slide by slide. For example, if I click here, slide, and another one, click another slide, and then you can again apply interpolation as we did before. It's also one way. Yeah, for example, I have example of the teeth, like dental. So you want to segment individual teeth. So you go to layer by layer, and you see that most of teeth sometimes they have a gap. So you can just select individual teeth, and then you can interpolate the teeth and use this interpolation for watershed segmentation. So that's also some kind of application of this magic wand tool in combination of the segmentation workflow and watershed segmentation. Okay, the next one would be a clear. Let's say this propagating tool is not really useful because you have to propagate the tool, but maybe you can see it from here. So for propagation tool, what we need to do is just to define, for example, let's say if I want to select this dot here, and you have to initialize. And after initialize, you need to propagate. They just start to expand from where you initialize to select only the neighboring voxel depending on the tolerance. So, but it's not really practical in this. If you need some very small detail, you might need this one. So it takes some time to initialize. Yeah. Okay. Here, and maybe I first select the setting by select the stop of the propagation time, initialization, volume, and here first, and then select time, initialize first. Yeah, it seems not okay. Oh yes, I have to, let's say, okay, I start here and initialize them. I have to select before initializing. After initializing, you can also start to set the time and to propagate the signal from the region that I selected here to cover the region that have similar intensity value of voxel. So let's say let's. Okay, I didn't get it to work. I wonder why. Sorry for this. So I will have to get back to you on this issue. Not sure. Okay, I stopped it. So we skip the propagating tool for now. Okay, now you can see that it's not really clever because it propagates too much because the way I set the parameter here. So it's not really practical using propagation tool anyway. So next one will be blow 2. So I clear because it has been select already. So I clear first, and then with blow 2 you can select to set the tolerance and the gauge width. So by default it's 35 and 4. You can see, for example, if you want to start to blow here, you can see that it start to blow in different spot. And if you want to have many things selected in the same time, you have to press shift like here. Also, if you want to select not this, you can also use this blow tool to select. For example, here you can see that, and shift over it like this, like this. So you can change maybe tolerance to 20 and maybe increase down here, and then I go to different layer like this one. Again, I just go maybe here, select, and if you don't press shift, if you start to blow again, they will override it. So you have to press shift and start to blow to certain region to have them all together like this. Yep. Again, we can try another slide, just one more with the blow tool. So here, and then shift, and then here. So it's really manual, and maybe it's not working pretty well for some certain image. So you need to, be careful about this. Okay, I hope this clear with the blow tool. And okay, that's what we did. And now the very interesting part is watershed segmentation. Before we doing watershed segmentation, just want to give you some introduction to watershed segmentation and the principle behind it. Yeah, this image. So as you can see here, this watershed, as you can imagine in nature. So if you have the landscape and you have the height of the mountain, so at the peak of each mountain or the crest, they will act as the watershed line. So when you have water or the rain coming up, they either fall into one side or that side, and they will collect it, so-called this catchment basin. So this is kind of representative of the, so at the peak, at the crest or the dam is the watershed line. So when the water or liquid come, they either fall into other side of this watershed line on the catchment basin. And how is related to our watershed segmentation? So look at this image. So we have on the left is a grayscale image. And to apply watershed segmentation, we need first to create a topographic image. So this topographic image or surface is kind of create the gradient image. As you can see here, we do image transformation from the left, from the grayscale image to right is the topographic surface. And the next step is that we can see in this demonstration here that first we have grayscale transform into topographic surface. And the next step, we virtually flood them with the fluid or liquid. So this blue signal is a kind of liquid or water. And see, you still keep flooding them until they reach to the point that the edge of this topographic image. So the edge is the height of this intensity. So it's the edge maxima. And you can see that at the end, after you completely flooded the full image. So what left is just only the watershed line. So as you can see, this line is representative of the watershed. So you get the final result of the watershed line that respond to the intensity of H maxima of the gradient image. Okay. And in terms of gradient image, so for example, in this chocolate bar here, we need to create a gradient image. So you can see the gradient is very strong between the background and the bright chocolate layer. And the gradient between the mousse and the chocolate layer is a little bit deeper, but still have the gradient. So this gradient has been generated. And we will interpolate this gradient image based on the intensity. So the high intensity can have the really high on the peak. So this H maxima is higher. And then we can also expand this gradient image into this. As you can see before, we have just grayscale image of the chocolate bar. And when you transform this gradient image into the height map, you can see it's like this, because the gradient between the background and the chocolate layer is very strong. So you can see that the map is very high map, and the inner layer is a bit lower, but still now you can see that we have 3 catchment basin outside, middle, and in the innermost one. And for watershed segmentation to work, we need at least to fill in the markers in each catchment basin. So now in this image on the right here, we have 3 catchment basins, so the outer space and 2 inside the catchment basin. So we need to run watershed segmentation, but you need to also define the marker. Marker is where the starting point. So for example, if we have 3 catchment basins, 1, 2, and 3, A, B, C is 3 catchment basins. And if you define the markers, only 2, for example, I have marker A, red, into catchment basin A, but I have only 1 marker in one of the catchment basin B and C. And when you flood this with markers start to expand until they reach at the watershed segmentation line and they stop. So that means the red markers start to expand until they reach watershed line, they stop, and the green marker, because we have only 1 green marker that not defined for B or is too low for B, so it overflow on the B. So that's why even we have 3 catchment basin, but the only 2 catchment basins separated. That means if you look at the example, if you have only 1 marker outside and just 1 marker inside, you can only separate 2 layers, so the background and the chocolate bar. So for watershed segmentation to work, you need at least 2 markers, so outside and inside. But if you want to have efficiently separated all the layers, so you have to have individual material have each marker. So now we get back to the chocolate bar here, and then I will start to show you how we do that. So I remove everything and go to full viewer like this. So for watershed segmentation, we need to create markers, and how to create markers is really easy. So you just go to one of the materials. So for example, start from background. I want to define a marker for background, so I paint it with a brush tool here. For example, like make sure you just paint everything from background without any part of layer, or you can paint it more here. And then I assign this paint or mask voxel as a marker for background, yellow one here, by clicking assign. And then come to the chocolate, and you can see that when you assign to individual material, the color also corresponding to what you are assigned here. So next one, chocolate green. So I just paint it here, and then I will assign this for green chocolate and click sign plus here. Now you can see it's turned green. And last one, mousse. So I just try to avoid the little dot. So just go, you can even go, but just go on the same plane like this. And you can see this selected material in the gray material. And now we assign to this pink mousse and click assign here. So yeah, now we have 3 materials, and you can see yellow for background, green for chocolate, and pink for mousse. And these 3 colors, so we call it markers. So as I told you before, we need 2 markers at least to run watershed segmentation, but here we have 3 because we have 3 phases: background, bright chocolate, and then gray mousse. So at least you have individual marker for individual phase. And then now we need to run watershed segmentation. That's from the previous screen. So we need to run watershed segmentation because we already have 3 markers. And to run watershed segmentation, you just need to select this watershed is number 8. So if you press 8, it will go to watershed segmentation. And for watershed segmentation, we also need to create a gradient image. As I just mentioned here, the gradient image just to act as the watershed line. So you create one gradient image, and this gradient image is just gonna act like a dam. So imagine you have the 3 markers, and markers start to expand until they reach the watershed line and stop. So I will show you right now. So with the watershed segmentation, so you need to create a new gradient image by click this button once. So now we have gradient image generated. And after that, you just click apply and create a new label field. So once you apply this, they will apply watershed segmentation algorithm and calculate. What they do is that all the markers, for example, yellow marker for background, start to grow until they touch the watershed line, which is the gradient image. So it's the border around this chocolate, and then stop. The same for green and pink, they just start until they reach at the border and then stop. So I click apply and create new label field like this. As you can see now, everything is been growing. Markers start to expand in that direction, and then they touch this watershed line and stop for all layers. Okay, and then you can see that really easy that you can segment different region. And go back to the project workroom. So to explain you a bit more in detail, this okay. So what we have first, we have this chocolate bar like this, and then I click create a new gradient image. In this watershed, the option here, once you create a new gradient image, you will have this gradient image that look like this one. And again, if I visualize this gradient image with height map slice, and you can see that you can change the color map of the height map slice. For example, change to physics, and then you can adjust scale of the height map to amplify them. So as you can see that how you can transform from the grayscale into gradient image and topographic surface just based on the intensity. And then I just visualize so-called what we added, the markers. So I just use box light rendering. Yeah, it's on this side, so maybe I can turn back this way and then change the offset of the height map slide this way. Okay. So now hope it makes sense. So what I did is transform the grayscale of chocolate bar image into gradient image, and then based on the intensity, it acts like a height, so become watershed dam. Yes. Yeah. What I did here is just the grayscale image, and I just what we see here, we just visualize them. That to take it out, it's just only information you have here. It's just only intensity. Yes. Yes. You can do by going here, gradient image. You can also create any gradient image and import to watershed segmentation. So gradient image gradient. You have attached this module image gradient and then apply. You will get the same image like this one. Pardon? Yeah. So if you look at the model of image gradient, they just transform. So we use the gradient type canny, but you can select different type of gradient, and you can use this option. So yeah, not much I can tell, but mostly they transform the intensity into height map slide like this. Okay. So because I which one that I this one delete. So go back to this height map slide and all the markers. Remember, I transformed the chocolate bar into gradient image, and then I manually paint only a few markers for each catchment basin. As you can see here, they have at least 3 basins, but here, and each basin they have corresponding markers that I added: pink, yellow, and green. And when you start to grow them, you should see the final results that look like this. And maybe I just go a bit down here and link to the column map. So I have to create again another column to show you. Create column map region and chocolate auto slice. And you can see here. So when you apply watershed segmentation, this marker will start to grow until they touch watershed line, and then you get finally the result of the 3 layers separated. This is the really sophisticated one to separate object. And then if you look into 3D volume, yes, again, I can also go back to segmentation workroom and delete the background by delete it. And then go back. So I get, I did the wrong one. Yes, so I delete the background and go back here. So I should get only corresponding of the chocolate bar segmented nicely between the mousse and the chocolate bar itself. Is that okay so far? Okay. So that for watershed segmentation and also segmentation workroom. Let's say we go to the new segmentation workroom because you will see the difference, and maybe it's also good to continue it like this. So to switch between the classic segmentation workroom to the new segmentation plus workroom, go to Window, and then you can see this. They have the option switch to segmentation plus workroom. Okay, what new about this new segmentation plus workroom? As you can see that they slightly interface, they have similarity in the interface, but here you can see that now you can zoom in, zoom out easily. You don't have to browse to zoom in anymore. And the way they interact with the image is much faster than the previous classic segmentation workroom. So you can see that you can use mouse to interactively zoom in, zoom out in the images. And each image, each plane, you can also change the dynamic plane of your color map. For example, adjust this here. So this is also one improvement. And now we also have all the tools on the top right here that we're gonna demonstrate right now. And also, what can I say? Because in the future, we want to merge both classic segmentation and the segmentation plus workroom together. So everything will be transferred to the new segmentation plus workroom. So we're gonna use the new one. So I load some file to the folder. So I'm gonna use this one for demonstration of the new segmentation plus workroom. So it's somewhere here. It's called so this form for segmentation plus workroom. And if I look quickly into these images, and it looks like this: form, porosity. And again, if I add volume rendering like this, and this one will be a good example for region growing of Magic Wand 2 as well. So we're gonna use this image for new segmentation plus workroom. Okay, so I'm not sure if you load this example, but if not, we can follow this and then we can try later. So I load this form.am and go to segmentation workroom. Make sure it's on the segmentation plus because you will see everything on the right. If not, you just go to Window, select, switch to the Segmentation Plus workroom. And first thing you need to do that is slightly different from previous segmentation workroom, that you have to load the image. So it's not automatically detected. So you have to select which grayscale image you want to load, because I have only one form here. So I just select the grayscale image to be loaded of form.am. And I can also select to view only one viewer. And you can switch between these 4 viewers by cycling around. And when I'm in one panel, if you don't see anything, just assume that the dimension is not right. So press spacebar until it comes to the viewer like this. So I have only one viewer, but you still can cycling between a Y set here and X set here and the 3D viewer like this. So I hope you see, or you can see the 4 viewer. So X, Y, Y set, X set with the color map that you can adjust it here. Okay. So now I switch to one viewer first and go to X, Y. So next thing you need to do is also create a label field or label image. So here you don't have anything created, so just create new label, and the new label also appear here, and you have the list of material to be created, same like before. And just similar thing that you have material 1, you can create the new material, create new material. So material 2, let's say go to red, pink, like this. So you can add many more material that you like. So let's stick with the tool. So we have the brush tool as well. So okay, if you remember, you can brush and paint everything. So if I do it here, you can paint only everything that on the image. But if you would like to clear them, so now all the tool that you see before on the top bottom left is shift to the right. So you can use this eraser to clear the selection, or you can like here. But if you want to completely remove it, just press this trash bin. So everything deletes. Okay, one more time. If you just paint like this, and you can also use eraser just to do this, or you can press Control as before. The same thing, Control and erase. Or again, if I do just you paint like this and press F, it's fill. Control to erase it a bit like this. And then if you don't like it, you can also delete it by clear selection here, or you can undo or redo. There's also some option that very good, that sometimes by mistake you press some button that you don't want to, you can still redo it or undo it. That's also some kind of new feature that we didn't have before. And then clear all selection. That's the paint tool. And which paint tool we can also use in combination of this masking here. So underneath of this material here, you can see masking. It's hiding, but not hiding, it's activated, not activated. To activate, just click hide, or just click activate them, sorry. When you activate, you can see the mask coming up. You can also play around with mask. For example, now I mask only the black porosity like this one, for example. So now you can paint. And you can see this, they only paint on the area of the mask only. They don't paint onto outside of the mask. It's only inside the mask that has been painted. So this one will be, sometimes it make easier for manual segmentation instead of try to find some way to paint very small details. So this will be good for you to use the brush to paint in combination with mask. Okay. And next two is magic wand, which already see before, but this time maybe this one could be very interesting to show you like this. If I change this object here, so you see that it's not all connected because there are some parts. If I select here, you can see only one region has been selected. If I want to select more, you can select by press shift and select different object like this. Here. Does this make sense about this magic wand and legend going different between threshold, because threshold you mask everything at the same intensity will be selected. But with magic wand, based on the legend going and the mask of the threshold, you can only select the object that have the same intensity that connected, and also in the range of intensity that you select. So I have the range here 0 to 16. So everything else will not be selected. I hope this is really clear to explain about the magic wand and how you put. But I have to press shift to select a different object at the same time. And you see here they are connected each other. That's why they selected. And again here. This is how you select a different object and add to your materials. Any questions so far on this two? Okay. And next one, this also completely new. Okay, before I go to this, just go to this list that I mentioned before. We also have this, for example, interpolate. So to do interpolate, I just do it like this. Clear selection, and maybe you go browse between different slices. Browse here. If I, instead of use, okay, I can just use quickly. Like here, 3 slices here, 3 objects here, and then go to maybe over here, like this. And if I look onto 3D, I have like 2 slides selected, and you can just easily use the interpolation tool. So interpolate them like this. Okay. You can also do this quickly, fill hole. So you can see a lot of hole. You can select fill hole. So the hole have been filled. Again, if I undo it, there are many holes. So you have the option just to fill hole or closing. And then most of the hole that used to be like in a gap will be filled. And the next one is the shrink. You can see that I can shrink this label that you select, will shrink. But because I select shrink only the current slide, you see the current slide has been shrink, but not all the volume. But if I change to all volume, and then again shrink them, so everything will be shrink. Oh, sorry, I have to go to all volume and shrink them like this. Or you can grow them back using the grow button, volume, or slide like this. We also have this invert. So you invert the selection, and then you can have the selection invert. But what been selected before is still there. So, but just to show you here, before we have, I used magic one like this and this. Okay. And okay. So for invert, you just select these 2 here to invert them. Okay, invert them again. And the last one is just smooth to it. Not much you do it. You can smooth the layer. Yeah, it's more like closing some gap. So this is some tool that added and make it easier for manual segmentation, as you can see. And the last tool here on top that I want to present, the last one is called Super Pixels. Just clear everything. Look at like this. Okay, well, so for Super Pixel, you need to activate them by press here and select the cell size. So it's gonna take a little while to activate them for the first time. Sorry for this unresponsive. Any question in between? So, and after that we can go for, yeah, now it's coming back, go for lunch, not for lunch, for a break. So in this Super Pixel here, we need to define the cell size. So by default it's about 40. So if you change cell size to 20, for example, and you can see the mesh or the cell size has been defined. And when you have this, you can see you can easily draw different part of the object. Just here. So easier. Again, if you overdraw them, you can also press Control. The same thing like you use Paint tool. And if it's not enough, you can also always define the cell size, or let's say to 10. Yeah, and you can get even more defined region to draw and paint different region. Yeah. So any questions so far on this? I think it's really handy tools, and you can assign to the material that we did before. I know all these example you can also do automatically using this general module, but yeah, it's something that maybe you can apply to your difficult data. Sometimes it will be maybe shape that you have to follow them manually, and maybe this thing could be interesting in combination. Yes. Yes, it's available now since 2022. So the latest version. So you have to update it, and you have to make sure that you just switch to the right segmentation, because now it's kind of experimental phase. We still have workroom, the classic, and the segmentation plus. But in the future, we will merge them together, so you don't have to switch any. But first, you need to understand the principle of this assigning material into the mask workflow into each material. And when you understand it, you can also use this tool to start to create your mask workflow to the material. Okay. Yeah, I think we'll come back and then explain a bit on this new AI assisted tool. But now let's take a break for maybe coffee or some water. So quick question from the back. How can we calculate this surface area? For example, you can easily use this magic wand tool, and I maybe clear first like this. Okay, and adjust threshold. For example, I have the bright and the dark. So if you just select with the magic wand, only this area, for example. Okay, and you can see that in here. And then what I do, I just need to add these two material one. And when you go back to project workroom, you will have this object here. And from here, you can easily calculate the surface by using label analysis. And here you can use list of measurement. You can, for example, you go here and you just select, for example, standard shape analysis, that you can see they have volume and area, or you can use the custom created like basic 2D. Basic. So it depends on the list of measurement that you want to measure. So you can always select what you like, and then you measure them, then compute the object to be calculated. So let's continue still with the segmentation workroom. One last part that I didn't mention yet. Going to open the new image that used for this specific case is the TM image. This one, EDM 8594. So it's also in the folder that I uploaded to the website, EDM 8594 to UH00. Okay, you can see it here. So I just visualize them with auto slice quickly. So these EM images, and as you can see, it's really, really difficult to automatically segment it. Why? So let's say before doing anything, you should apply some filter. And in my experience with this EM data, it would be best to use recursive exponential. So you can try with filter sandbox. So add filter sandbox to this data, and you have this their own sandbox to the image like this. Enhance the contrast a bit more to see like this. Okay, So in Filter Sandbox, you can just select, yes, that's what I said here, recursive exponential is quite good for EM noisy data like this one. And you can see here the preliminary results of the recursive exponential, but still really difficult. Apply. And then you should get the images that look like this. And in terms of difficulty, in terms of segmentation, that's why we need the segmentation workflow. I will show quickly. If you want to do interactive thresholding, for example, how can you segment only like one certain structure like filament or mitochondria? So the answer is no, not possible with this automatic segmentation. Interactive thresholding here, like this. So now I want to apply threshold. For example, you want to segment only the membrane, or not the membrane, microtubules, yeah, the filament, the microtubule, or even or just mitochondria or even vesicle. So when you see that because they have the same intensity, when you try to threshold him, you will get everything that have the same intensity. You get ribosome, you get some membrane or vesicle, and also microtubule. So that's why it's impossible to manually to automatically segment it individual feature based on its intensity. That's why we need later maybe deep learning and AI assisted tool to segment these kind of images. And also that's why also important why you use segmentation workflow. For example, you want to use some kind of drawing or even the super pixel that you can kind of segment it into small cells or jigsaw, and then you just select it only a few parts. Yeah, now I go to segmentation workflow with these images here. This one. So I will use this one just for demonstrate on the segmentation workflow of the filter. Go to one viewer. This one. So I have to load the image first. So go to grayscale image and select the one with the preview. So which one is this? So I renamed them just to easily find the image. F2. Let's say the second image like this. Go to segmentation and select image number 2 and one viewer. Yes, like this one. Again, I change the contrast a bit more. Like this. Yeah. So quickly, so if I, for example, try to use this magic wand tool, so if I want to threshold only the filament, maybe something like this one, but you can see that it will be difficult to really use it. For example, if I want to select here the object, you have to follow many parts of them to really segment it like this. And in for viewer, it's almost impossible to really see the things. Yeah, see it. As you have to do it one by one. That's still manually a lot of time to do the segmentation. So what we do is you're gonna introduce the new tool called AI assisted tool. Just one more and zoom out. So clear everything, selection. So in Avizo, we just introduced in this new segmentation workroom called this AI assisted tool is on the tools here, tools, and you select the right one, AI assisted tool. So you can see that when you select the AI assisted tool, there's that you need to create patches to use AI assisted segmentation tool. So we need to create patch. So select create new patch sets here. And then you just have to define the patch size. So let's say 32 should be okay. So now the patch set has been created. And once the patch set is created, you can see there's the sign of the stamp here that you can stamp the patch into your image. So maybe, yeah. Sure. Yes, and you will see it right away. So if I click on this patch set here, and you can see that the size of patch is over here. Yeah. it's gonna be bigger. Yeah, for example, and the reason I do this 32 because it's gonna be easier to paint and to define the region. So if you have 64, it's gonna be double the size of this passage with this 32. And now because we have, at least I know that we have 4 structures. We have the vesicle membrane and mitochondria with the membrane, and this the filament of the microtubules, and little dots here of the ribosome complex. Yeah. So it will not be easy to really segment them. So what we do here, we use AI-assisted, is kind of pre-deep learning. So after we create patch, click on this stamp here to create to stamp the patch into this object. So the aim here, we need to stamp patch as much as possible, or at least some patches. So I stamp here on the vesicle, make sure that I have some membrane of the vesicle inside. So I'm gonna do one by one. So I start segment the vesicle first. So I just select the vesicle, have the clear membrane here, for example here or here more. And you also need to create patch with empty membrane information stuff to serve as a background or the control. So here, the thing patch that doesn't doesn't have a membrane of the vesicle inside. So like this, you can see that I create maybe 4 patches with a membrane here, 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 and here, and another 4 patches without membrane. And then we need to define what is the membrane inside of this patch. So I'll use the brush tool again. And with brush tool, you see that masking is activated. Just maybe inactivate them and change the brush size. Maybe I can zoom in a bit more first. Something like this one. Okay, because all my patch are over here. So go back to paint tool and maybe adjust brush size. Here you can start to paint the membrane here, here. So if you spend more time to accurately paint the membrane, you will get a better result. So this is also important for deep learning. It depends on your ground truth image. So what I'm creating now is the ground truth annotated manually. So you need to spend really good time, more time on extracting good annotation of your ground truth. So the more you have accurate ground truth, the better the result you have. You cannot expect to like draw something really roughly and then you expect to get a good result from deep learning. So when I have this annotation created, you just select onto your material. So I have this material 1, but you are going to change to let's say vesicles membrane like this. So I just select this vesicle and I add this selected from paint here to my vesicle. And now it turned to green. So maybe it's difficult to see. Let's say, is it better with yellow? Okay, so you see that what I painted, now it's been selected as the vesicle material name. And if you look, zoom out a bit, you see that I have at least 4 patches that contain this yellow selected material and 4 patches without material thing. And now we're gonna run this AI assisted tool. So if you click on it, AI assisted tool, and you can see here we have material to be run. You need to define patch size. It's not to define, we already defined by the beginning. So you can later, if you want to try bigger patch size or smaller, you can. I think this is smallest 32. You can also have the biggest one. This morning I run 128 or 256 patch size. And then you define number of epoch. So for deep learning, in one route that they go to the software to do the training, go to all the data. So one route, one cycle of the running of the train and validation is called 1 epoch. So by default, it's 20 epochs, but you can also increase it. You get 100 epochs. And elastic information strength, yeah, difficult to explain, but try to use this default value. And then you create selection. Oh yeah, before we running this, we need to set the environment to be compatible with deep learning. But I will show you later how to create this Python environment for deep learning. So you select create selection. So the AI assisted tool gonna run for a while, and then you should get the result soon. Let's take a look because I didn't prepare very well in terms of drawing, and just only 4 slides just to give you a rough. You can see now they try to detect it part of this membrane. Maybe the patch site that I select is not good enough because they also detect this mitochondrial membrane and some part of the microtubule. But at least you can imagine that how this thing, you can also, let's say now I go back and create more patch, let's say here and here and here, just to give them more accurate training. And you can go back again to the vesicle and add this select patch, and then run again these two, just rerun, like do training again until you get a better results. Or that's what I do. So I'm gonna load the result that we prepared from this patch generation. So if you go back to the original data and look at the volume, this one volume rendering created, you can see that actually the images look like this. Yeah. So be this good contrast. As you can see that many of the object has been segmented. It's still not so accurate because the way I only spent a few moments to paint them, but some of them are quite nice already to start extract that membrane. If imagine you spend more time on spend more few slides extract this, sometimes you will get this kind of roughly ground truth image for later do the real segmentation on deep learning. Okay, this is only one structures of the vesicle. I will load the example of the total results. So I go here and get to. And you can see here, it's the same images, but this time we create at least 4 material for 2 segmentation. You can see that where is it? Here, create new label, and in patch you can see we have at least 4 patch sets, so vesicle patch sets like this, and you can see by the way they generate patch, and you can browse to each patch here. That where they start to spend a lot of time to look for the nice area where you can create patch. Okay, get the patch set. You can also change to 64 patch, for example, and then you select the patch mitochondria vesicle patch set, and yes, yeah, and yeah, okay, and look at the results of the vesicle annotation vesicle label here. As you can see in this example, so you just try to annotate this vesicle, this area, and you just stamp your patch into this region, and you can go to different slides to find region that both with and without the patch, like you can see here. So
can I ask
yes.
Can I ask a question? So
sure.
You create one patch set per material you want to segment, and you run the AI segmentation tool one time for each.
Yes, exactly. Exactly.
I see. So you cannot do like multi-class or multi-label.
No, yeah, you have to do one at a time. For example, you have here, you see the result, we have different patch set for each material. So we have one patch set for vesicle, one patch set for mitochondria, and so on, like also and microtubule. And each of them you have to, like, for example, I didn't have enough also background. That's why you see that you have to also define this microtubule membrane and mitochondria membrane as well to distinguish them between the vesicle membrane. That's why my result initially is not good enough, but you can see here there are a lot of background. That's why you should put effort on painting and also put more background as well to distinguish the different membrane from different structures. Like here, you see they also have this patch with the membrane of the mitochondria. That's why you get a better results. Is that okay?
Okay.
So far? Yeah.
Yeah, so
And
you
then,
end up, so in this example, you end up with multiple label fields, and then you have to integrate somehow.
it will be combined in one. For example, here when you will get all these results. Like this is combination, but if you just look at individual, you will have one label for each material. So you see that you have one label for vesicle, another label for mitochondria here, and another one for liposome and microtubule here. So that's it. And then we just combine them. Yeah, easy. Like
So you can use
image.
arithmetic, for example.
Yeah. Or merge image. So yeah,
I see.
exactly. So this is a combination of our labels, but individual label you can see here, for example, microtubule. And in this example that we will see tomorrow, for example, you can use this as the input ground truth image for deep learning, for example. So instead of manually drawing online, and even with the mass tool or the superpixel, you can still not draw this so accurate like this. So it's better to use the AI-assisted pre-deep learning. When you have this, you can also run deep learning using this as the input for a ground truth image. Yeah, but we will talk more on tomorrow on about deep learning and all these things. But this thing is really useful, and you can see that really, really nice already. Imagine if you before the deep learning, everything has to be done by hand, slide by slide drawing, and then you can ask your PhD student to draw this for a week or a month until you get final results like this. So I hope this.
Can I just add a comment since we're talking about hiring students? So actually, as Sarawuth mentioned, like you have to do sometimes a lot of manual segmentation, and sometimes it's tricky to do it with just a mouse. So in the Viz lab, we actually have a new kind of pen and touch interface. So you can use a pen to kind of brush directly into your data. So it's really helpful for speeding up manual segmentation. So if you want to use that or learn more about that, you can just send an email to help@viz.kaust.edu.sa.
Thank you.
Yeah.
Yeah, thank you. So that is about AI assisted tool. So we have this data deposit in the website, and if you like, I can send you this complete project to give you an overview of what we did. And yeah, but I didn't upload the full project, so the data, but yeah, I can later deposit all the complete project, and you can see this. Okay. So if you don't have any further question on this new segmentation workgroup, including these new AI-assisted tools, then I will go further on the next topic. Yes.
Can we say?
You mean here? That's a good question. So I didn't think about if they already store this model somewhere. No, but what you could do, you could save this asset and you can use for the different images, but not the model. So because I'm not sure if they store the model somewhere. But yes.
Mm-hmm. So each batch we need to have like each one.
Yeah.
So it's already what they multiple.
But you can save this as a project file, and you can save individual this. You can see that we have this file here called patch set. I'm not sure if we can visualize them. No, we cannot. Display. Yeah, we don't have this. It's just patch set, but everything is been saved here, and you can use it. But I'm not sure if you can use it for the next images, because imagine the patch set that you create, is it manual created? I'm not sure it's going to be exactly precisely can fit to the other images. Yeah. Yeah. Yes. Yeah, no, but that different. This different. That is just only more AI helping in segmentation workroom. But tomorrow we're gonna go to real deep learning. That you're gonna see that we can generate the models, save the models, and then we can run prediction. Okay. Yeah. Yeah. No, you can train one similar image. One, for example, if you have this image here and you have similar of them, maybe 100 of them, you can just train one image. And you create one model. It's called architecture file, and you create a weight file. Then you can use this the model to train the rest of your image that have similar structures based on this image. But this image, you need to create a segmentation ground truth that has to be very precise to get the good quality result. Yeah. So since we're talking about this is pre-deep learning, and it's not real deep learning yet, and still not many information you can get from here, but just to help you segment things easier, faster. And the next one will be deep learning. Machine learning. So I'll go back here and select the corresponding file. On machine learning. So with machine learning, we need the classic segmentation workroom. So sorry for this. So take a look on to this data. So this is also EM data, and is the hard tissue. And you can see that they have at least 4 distinguished patterns. So we have this very bright membrane and some internal lumen of the mitochondria. So this all this structure here at mitochondria, the very bright membrane here. And we have this actin myosin filament. So it's like fuzzy zone, where you have this interconnecting of the actin myosin filament. And the next one is like hard tissue. So it's kind of grayish and with some dark background at the back. And we have even these T-tubule structures here. So T-tubular system. And also really difficult because it's very dark lumen and some bright but not so bright like mitochondria. So if you use intensity based to segment this image, it will not impossible because you can see that some intensity is shared between all of them. So we going to introduce the new machine learning tool. So this machine learning we call texture classification. As the name suggests, is texture-based classification. So that means you define the texture of your image. So it's not going to based on the intensity anymore, but you based on the repetitive pattern of the image. So you define the region of image that have similar or repetitive pattern, and then you run the machine learning. So let's go to segmentation workroom. And as I mentioned, for machine learning, we need to switch back to the classic segmentation workroom. This one. And go to one viewer, and this, let's say here, should be okay. And now I don't get used to this zoom in, zoom out anymore because it's so easy with the new segmentation workroom. Anyway, so I try to maybe look at maybe X, Y, yeah, like here, and zoom in maybe a bit more here, like this. So what I do now, you can also zoom out or zoom in, but try to get overview. Just only one slide. You just select one slide that you can see all the features easily, like this one, slide 90. And the same like segmentation, you need to add 4 materials or 4 of the structure that you are interested. 1, 2, 3, 4. So let's say I say this one is mitochondria, not mitochondria. And second one is T-tube. And this is filament. And the first, last one is tissue, hard tissue itself. Here. So you can also change color. Go on. So same thing, we need just to define the region of the same pattern. So I use brush tool again, and you can also adjust brush size. Yeah, maybe here. So with mitochondria, so I paint it somewhere here. Let's try to cover on a membrane as possible. Also the same like deep learning, that you also need to kind of spend some time kind of paint them. Just only one slide should be enough. Just to keep all the information about your images. Like here, maybe a bit here. So this should be mitochondria. So I go to mitochondria and add it. So now it's highlighted as green as for mitochondria. And then for next one, T-tubule, just reduce the brush size, and maybe here, have fill here as well. This T-tubule network here, and bit here more. Okay, that should be covered. Go to T-tubule and add. So that's second, and next one is filament of actin myosin filament. So it's over here. Or you can increase brush size. And I can do here as well. Yeah, I do it quickly. It's not so accurate, but if you spend more time on it, you get a better results. So add to the filament. And last one, the tissue itself, the hard tissue. Have to fill. And add to tissue. You have this little part here, go to again filament. Yeah, and then add to filament. Yeah, so now we have all the structures painted. A little bit here. Yes, for tissue. So you can see that mitochondria in green, mask and tubule in red, filament in blue, and tissue in yellow. So to run machine learning, we need to go to this texture classification. So shortcut number 9, you press 9, you go to the texture classification. So just define the radius of the pixels. So let's say 25, and can do the interpretation in 3D. So ball, and maybe increase pixel size to 3, let's say 5. And then you can select auto compute just to see how the general computation coming up, maybe too much. So yeah, something like this. It looks pretty okay. And then you just run, and that run to find the similar pattern that correspond to this marker for all images. But yes, I already said that because I didn't paint quite so accurate. You can also expect that the result will be not that so good. But yeah, that's the principle of the machine learning. So take a little while. I only paint on one slide only, and then when they complete, I just apply all the algorithm into the full stack of the images. And when you finish this, you can also use this each material at the starting point for watershed segmentation to improve even further your segmentation. You can do that or not, but it depends on you. So, but just give you some information. It's also a possibility to use this as markers for watershed segmentation. So that means if you want to run watershed segmentation, you just go click on the watershed segmentation here, and then create a gradient image and apply watershed segmentation, and you get some improvement on the segmented data. So you can see here most of objects segmented. And what I said before, if you would like to run watershed segmentation, you can go to watershed segmentation tab, create new gradient image, and then run again the watershed segmentation using this as the marker for the starting point. And take a look on the results. So if I look at my image here, so I create label color map. We have the color as I wanted to see, and then overlay the result with color watch. And to see object here, that should be this one. Yeah. It's strange. I try to add color watch to this label, but not. So this original data, okay, I'll try one more time. And data, yeah, sample and set transparency. So before, after we run machine learning, you get the preliminary result like this, and then after apply watershed segmentation, you get pretty much most of area covered. So like this, follow different structures. And let me load this completed data that have been prepared before to give you example.
One question.
Yes.
It's a machine model property that you just showed.
Yeah.
Say, or is it to be part of one of the pipelines?
Actually, no. I think you need to create a new training image every time for this machine learning.
So we have to save this project.
Yeah.
Be safe on the.
This is the same like I save it here, so you can have this, but I'm not sure if you can reuse for different data set or not.
Okay.
Yeah. I think no, because if you look here, and if I overlay them, this is the more accurate results. And if I go to, you can see that they follow this trend structure nicely. And if you look on the segmentation, we only create this kind of label over here. It's just only the label. So I don't know if we can really save the model or the structure to apply to different.
Use models as ground truth for the deep learning.
I think that's possible. Yes.
Possible?
Yeah. Because it's the same segmentation, so you need to just generate this label image. So if you look on this result itself, where is it? This one in volume rendering. Yeah, so actually you get this object like this. And if I maybe set opacity here and create the volume rendering of the original image, so you can see here that that's how it's been segmented for each region. So yeah, definitely. So you can use machine learning to segment this, but it depends on the structure you are segmented. You have to be based on the repetitive pattern, otherwise it's not going to work. Yeah. And you can see here they have the if you go back to segmentation and look on this documentation of the machine learning. So we have the texture classification. You can see that texture classification reference is based on like repetitive pattern. How you can detect some example to segment it. If they don't have enough any different in terms of the texture, they cannot detect it. Okay. So yeah, I will remember to load these two projects from deep learning, the CNNX work and this machine learning to the file in the website as well, so you can load and see them and try to repeat this training. Okay. So now I think we finished the segmentation workroom, and we come back to automatic segmentation, but also related to watershed segmentation as well. So open the data from your program file, C program file, and select this folder from 22.2 in data folder, looking at maybe tutorial and tutorial advanced, image processing advanced, and select home.poro.am. So data, tutorials, image processing advanced, and then select foam.poro.am. And you can see this is foam bubbles. And if you look on to volume rendering, it's looking like this, like a cheese. In this example, we're gonna do automatic segmentation using watershed segmentation in the module called separate objects, and then do calculation, for example, shape size distribution. So starting from beginning, you can see that it's very noisy and very pixelated as well. So easy to use median filter or filter sandbox and see which filter that give you the best smooth effect. So, but for me, 3D median filter of 3 iteration is good enough. Then live, and after the filter step, you should see that it's smooth like this. Yeah. Next step is I would do interactive thresholding and threshold the foam bubbles like this. Okay, and then click apply and look at the foam bubble here. You can also remove this part that are touching the border because maybe it's not so accurate, but we can do it later because now we're gonna remove everything. What we could do now, we're gonna separate them. This is the module I was talking about. So before we have here before separation, you see all objects are attached to each other, but we need to separate them based on vertical segmentation. So how can you define the marker? So with the module called separate object, they can use this H maxima to define the markers. So to do this H maxima, you usually have to create this distance map, section for distance map, like this. So they create distance map from these images, and these images gonna look like this one. As you can see. So explanation a little bit. How you had label image like this. When you transform into this distance map, they start to the outermost pixel at the border, for example here. So they start to detect the pixel that have value of 1, and then the closest to the border or the next at the border of each label image, the value of this pixel will transform into 0, and the wall they propagate inward into the center. The intensity of the label or the pixel is going to increase until they reach into the innermost of the image like this. So if I overlay them quickly, maybe to give you some here, and then like this, as you can imagine. So first we create label image, and then we use this distance map, chamfer distance map to transform this label image into the distance map. So this explanation is start the value of intensity of the label image from the outmost pixels to have 0 value, and then propagate until they reach the center of your image. So you can have the brightest signal in the center. This is how this distance map can be created like this. And then from here you can create H maxima. And let's say, and you can see that in H maxima you can define the level of the separation or the height of the vertical segmentation. So the lower the H maxima, then how two objects can be split. For example, you can see these two regions here. So let's say I do 2, and you can see that it looks like this. So maybe overlay again this one with color wash data. You can see that when I create H maxima from the label image, the distance map, you can see that they have this H maxima here, 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 with this value 2. But if I change to, let's say, 8, very large, and then you can see that have less H maxima being detected. So when you run vertical segmentation, then you're gonna have less objects separated. So it depends on this value of H maxima here. And then for example, now if I go back to, let's say, maybe 1, you can get more H maxima. And the reason you don't see on every spot because you have to interpret them in 3D because we look on 2D. So if you go to some 3D object, you can see that one object maybe have the H maxima not in this slide, but in the lower or upper slide like this one, you have H maxima here. Okay. And after that, we just need to label this H maxima, labeling sample. And then we get this object. So each of the H maxima has been labeled. So if I look onto 3D volume of the H maxima, so you can see that everything like this. This is eczema, and this is kind of markers or watershed segmentation algorithm. Remember, we manually painted only 3 objects, but here with the thousands of the form, so it's impossible to really paint individual of them. So we just need to create the image label volume and then manually automatically use the H maxima to detect the center of mass, the gravity or distance map, and then run this watershed segmentation based on this individual S maxima value, that label. I hope it's not too complicated. And then we run watershed segmentation. But all of it you can just do in one module, in one go. So I just remove this shampoo, it's and mat and everything else. So from here, how we do is so-called separate object. And just visualize this one on 2D visualization. Like this. So in separate objects, you can see that we have this marker extend exactly the same, the contrast on the H maxima. So it's a marker extend the height of the H maxima. So the more of this marker extend, the more H maxima, the less object will be separated. And the less marker extend and the more object will be separated. So I will show you quickly. So I do it 10 and apply. And then you should see the object has been separated like this. Not much because they are on 3D. But if you change from 10 to 1, you can see that it's somehow separated here. Okay, maybe even too much, but just to give you an example. And then if you look onto the separate object module, they're gonna apply in the background watershed segmentation, and you can select the output. So just look at one by one. As you can see here, you can see the split object. So if you overlay the original label image onto with the split objects using color watch, here change color map to 256, for example, like this. So you can see the area where it has been split, as you can see in each the context list. And you can go to a different layer to see where exactly it's been split between the objects. That's one thing you can do, just overlay them using color watch. Or you can just look at the results one by one. So I have first the output split. The next one we have line. So they will show the watershed line. Will be exactly the line that go between of this object. So click apply. You can see this is representative of the watershed line that being created around the object. You can also again use overlay original image and use color watch to overlay this line with different color. Let's go to an basic again. So this is watershed line that they are represent where they separate the object. Or you can look at this next one, the basin. So it's just only the basin without watershed line. So click apply. So you can see this is how this the basin subtracted by the watershed line. You can see the gap between the basin, how they form into and separate each object. And next one is just basin without line. Basin 2, you can see. So it's not subtract. And last one is connected object. This one is just mass of the object that fall into this watershed basin. So you will have only the object that are separated and labeled individually. So click apply like this. So we get individual object. Okay, so mostly I just use the last result, so really easy, and then you can just take a look to them here. So now you can also take a look that you can also get rid of this using border cube, or you can use filter by measure range to the cube, apply, should get everything outside, and then only the inside object has been separated. And from this, you can just apply label analysis to get all the information or the statistics. For example, you use a standard shape analysis and click apply. And you get total of this porosity of 14,000, no, 1,400, so 1,400, and you get this shape distribution, volume, so on. area, and gray mass, and so on. And you can export this. And of course, this is automatic segmentation. You can always run batch processing, creating recipe, and then you can use it for the next time as well. Is there any question on this subject? It's really straightforward, just to explain a bit on how this watershed segmentation works inside separate objects. Okay, then move to the next. So because you were talking with something that I overheard, so maybe this one could be interesting as well. Tutorial. For example, I want to do the cavity analysis. So look at this object here, stone, and they have cavity inside. And look at the other slice here in this layer, maybe NYZ. So how can you segment some like open cavity? Because you can see here, especially here, this cavity is open to the background space. So it's impossible to do any kind of segmentation using a traditional tool. So because it's open to, like here you see, you cannot be able to extract the opening or ambient space. So what we could do is we need to create so-called using a module or ambient occlusion. So we need to compute ambient occlusion. What they do is the same like we did before. So we gonna generate the distance map from this label image. Okay, click apply. And with this ambient occlusion, you can see that distance map looks like this one. Okay, let's say overlay this distance map to original image. As you can see here, they start to propagate from the outermost until they reach to the center with a very high intensity like this. Or you can change more of the, but yeah, I hope it's okay. And again, show on this, maybe change color wash to, let's say, as you can see here, that from the outermost of the region, they transform to become very bright, and then when go inward, brighter, it go inward of the distance. And the same principle of distance map. And from here, you can easily use interactive thresholding to extract only the inside. So interactive thresholding and NYZ plane here. So you can see now you can threshold easily. So if I show you quickly, if I, instead of using this image, if I threshold the original image, it will not possible. It will not be possible. Yes, the reason that it's not possible because it's a grayscale image, so I have to transform to the label image. But that, as you can see here, we can easily extract this cavity by adjust the threshold to you cover everything like this. For example, and then you click apply, and what you see here is just volume of the cavity inside of this stone, like this. So if you have like some shell fossil or something cavity inside of something that you want that's open to the open space. Some example, if some you have like shells and you want to study the volume of the coil shell, so you can use this compute ambient occlusion to visualize them. So if I use another volume rendering and change label to 256, so the purple is original stone and the blue one is just the cavity inside the stone. You can also reduce the opacity of the stone to see the network of the cavity inside. Is this good so far? Okay. Okay, I still have a few more things to show, and then we should finish around 4 each. So next thing is to, let's say, register image. You have 2 image volume and you want to merge them or to register them to each other. Yeah, let's open data, go to tutorial, and it's in the folder called registration. Sometimes I have to think because there are so many folder. Okay, it's in registration. So data and registrations. And I open motor part 1.reference.am and motor part 2 model.am. Open 2 of them. And we attach volume rendering to the first one, volume rendering to the second one. As you don't see anything, you have to press this here to bring it here. So you can also change color map a bit to make it different from each other. Orange green and orange red, like this. So now we need to do is we want to register them. So one tool that we could do, so we have reference and the model. What you want to do, we want to move the model part to the reference part. So what we need to do, we need to activate this transform editor inside of this data of the model. So if you click on the model part2.model and in the property port, you can see that have the clock editor and go to this almost very last one is called transform editor. If you click to activate this transform editor once, so the model start to have this tab box. So with this tab box, you can use this interactive tool here, interact to move it around like this. So that's why if you don't have a mouse, it will be impossible to do this. But anyway, and you can see that you can rotate and move it around using the interactive tool. And you can also even scale them to shrink to expand them. But for the registration, please do not expand the size or shrink them because otherwise you will not be able to register because it is not the same dimension. So the reason now I'm gonna use the shortcut you can see here. In the hand to the trackball and the interact tool, you can press escape because it's gonna be easier. Now if I want to turn like this, change here, here maybe a bit more, here zoom in, zoom out. So even by hand, it's almost very easy to do this. Here, bring it close to each other. So I try to bring it close to each other as much as possible, and maybe a bit more like this. So even by hand, I can almost align them, but yeah, don't do that. So just to show you the registration module. So okay, here, and then once it's close enough. So the principle of the registration, you have to have at least some overlap part as much as possible if you can. Not maybe not gonna work very well. So after I bring this motor part 2 come closer to motor part 1, then I just deactivate this or you just leave it on. And then I go to motor part 1 and select register images. Register images. And in register images, you can see that model and the reference. Okay, then maybe I was a bit confused. So I can choose model as the model and reference as the reference. So part 1 here, or you can use the string. So reference to the reference, model to the model. And in the property part of register images, you can see that you have select different transformation. So in this part, it just reaches transformation because there's no shear, no translation or anything. It's about 6 degrees of freedom. And if you have shear, you can select have shear. You have also, for example, pre-alignment. You can align center and align principal axis, but it's not correct. For example, if I click align center, you can see here, just align like this, just pre-alignment. So you don't even have to do this, how you call, transform editor, but yeah, just to give you an idea that you can also do this. And because I click pre-align the align center, or you can also click on align principal axis as well, but it's not correct. then anyway, so I have to activate this transform editor again and pre-align them using this tool here, and move this one more time. So I think I totally messed up with the tool, so I have to turn one more time here and go around here. Okay, it's close enough like this, and be here. Okay, yeah, I think this should be good enough. And then turn off the transform editor. And now again, go back to register images. And this time I'm not gonna do pre-alignment. I just use the normalized mutual information. You can use the correlation, so on. That just use a default normalized mutual information and click apply. So they try to align. But I think I did something mistake when I start from the beginning. That should align perfectly. So I do one more time with the other example that be easiest one. So instead of motor, I do chocolate bar and model like this. And volume rendering here. So I have to chocolate bar again, and now just chocolate model, transform editor, change this to interact tool. And you can see that when you get not too close to each other, the volume rendering turn to become nice. But when they are overlapping, the volume rendering a bit fail to visualize both of them nicely. So now I just move it closer to each other like this. And yeah, almost there. Yeah, I think maybe I try to get a bit closer like this. And then ready. So I go to register images again and attach the reference part and then click apply. So they apply 6 degrees of freedom. So finally you get images aligned. But what you see here is only aligned, but they're not saved yet, because if you close it now, then everything you go back to normal because they don't save as a new coordinate. So you need to do so-called resample transform images to save them in the new coordinate. So this one, you have to go to resample, transform images, and then you can select to extend it and then apply. So you get this, the new transformation of the image that are saved into the memory. So because this one is, it's only visually transformed, but it's not really real saved into the transformation. You need to resample transform image to have this exactly here. You can also merge them. Okay, now I will merge images. I select merge and then select the lattice one, is it the here, and then apply. Now you get the new volume images here, and then I visualize them of the merge image with this one. So, but that's look nice with the merge. That's register to image volume. You can also register surface as well. And I introduce you another tool called landmark registration. So this one is more manual, but also help with the some structure that is not easily to find. So I go to surface.
Question.
Yes.
You have to overlay the two images like that for a big chunk. Is there like a minimal overlay that the partner needs?
They don't have minimum, but at least you have to have two image overlay, say some part overlay. And the more you have, and then the better they can align it better. But if you have very less, then maybe it's not accurate. So try to bring it as close as possible. Or, yeah. But if you don't have any overlapping of the two images, it's not possible to register. And then, yeah, any questions? And this one is just similar, but I'm going to do this one we have surface. So surface images like this, and the second image showing here. And this time we're going to do a landmark registration. So we need to create landmark. So with I will just go to somewhere here in the middle space of the project view, right click, create object, and then select landmarks to set with point and lines. Here, landmarks to sets. And in landmark to set, in the property port of landmark, you need to activate this landmark editor. In landmark editor, just select to show the lines here. Show line, and then go back to your landmark to set. And now we're ready to start to create landmark. So the idea here, before you create landmark, you need to make sure that they are like in close proximity, that you can create the point and line between the two objects. And then this point and line should kind of align, not too close like this, because it's gonna get confusing. So I will show you right now. So change to interactive 2 here, and then start to, you have to be consistent part 1 to 2, part 1 to 2 all the time, not to the other way around as well. So I start from part 1, I click the dot here, and yellow go down dot and go to part 2 and blue dot. Change here, maybe try to find a common landmark between the two objects. Not sure. Maybe here, you can see the 2 dot here. Yeah, here's 2, and then again. No. So I should delete this. Now I make a mistake, so I'll do one more time. Sorry. Create objects and landmark to set. Landmark to set, and then landmark editor to show lines. Go back to landmark, and then here I start to create landmark between the two. You can see that I try to align this landmark between the two objects from 1 to 2, not the other way around. Here, some common features, maybe here. So you can go around and to find more. Yeah, I think that should be enough for me. And here, instead of try to bring them close together, so we can use so-called a landmark surface walk. So landmark surface walk here, and just select the surface data to simplify surface part 1, and then click apply. So you can see the direction. You're gonna walk the landmark part 1 to landmark part 2. Click apply, and you get this one. Simplify and just select here. Okay. You can also close the landmark, and then you get object, and then apply the sample transform image to get these two objects registered with the landmark. So this is really useful because sometimes you don't have really regular structure, then you have to manually define your landmark between the two sets to really align them.
Yeah, is the images like this?
Pardon?
Do we have some tool for 2D images, for example, to
2D? I'm not certain. Yeah, I'm not sure.
So it's on the volume also.
Yeah, we couldn't. We haven't tried with 2D surface. Because usually Avizo they design for 3D information. You always need 3D information, but you could try. For example, you copy 2 images, or at least make it 3 copies, and then you stack them on top of each other, so they understand it as a 3D volume. But we haven't tried it.
What about top of each other? What about side by side? Maybe other tool which you can...
Oh yeah, we have it. Yes. So I'll show you quickly. Yeah, sorry, I completely misunderstood your question. So what you do, you go here, is in the data folder and align here. And let's say you open images like this one and take a look into 2D slice, auto slice, and XY like this. And if you go, so they have the 2D images like this. You can either manually align them. So align, slice, and here you have to do editing. And when you edit here, you can also like move this object around, but it's only possible on the translation. You cannot do the rotation. You cannot do anything else. So you can do, if you are in the image is not into, yeah, you see, you cannot even, you can rotate. I'm not sure. No, you cannot rotate this. So you can also do like align 2 pair slide like this. You can see they try to align the 2 pair, or you can automatically align all the slides together like this. But yeah, but it's more like you see the 2D of stack. I understand you mean the 2D side by side like this, right? But I think you could try with this transform editor. For example, if you have 2 images. Okay, let me open this and to understand what you asking. Register images. Let's say. So I think it's possible if you have this auto slide like this one, and second one auto slide here, and change color map to here. So what you could do, you can also do this, for example, transform editor here, and here you can do the same like 3D, but imagine then if you have 2D, you can just do the same thing by rotating, moving like this. That should be no problem. You think that would be answer to your question? And then you align, but I'm not sure if the module align center in registration will do the job, but it's more like stitching to the images. Actually, it's possible because we did this project with some customer. So the idea is that they have this 3D volume of the mouse embryo, and they want to align the 2D histosectioning into certain region. For example, they want to see where is the stain on the histosectioning on a 2D are located in a 3D volume of the mouse embryo. So you can align 2D onto the 3D surface. But 2D to 2D, we still really haven't really practically doing it yet. You know what I mean? Like you have the 3D volume and you want to see where is this 2D slide located in which level of the anatomical part of the embryo or the body. Yeah. And another thing would be also interesting in terms of alignment, resample transform image. For example, I open chocolate bar. Data. Tutorial and chocolate bar. For example, you have volume rendering here and overview. So if you look in the chocolate bar and I add the bounding box like this, original bounding box. Okay, now it look good. It look aligned to the principal exit. But if it's not, what you're gonna do? If you, for example, in CT scan, sometimes you want to have object that are aligned, but it's not possible because it's tilted due to the nature of the structure like this, and you want to tilt it back to align with the principal axis or some axis. So you can do that by use slide and then register and resample transform image to align the new axis to the reference axis. So let's start doing this. So now I just turn off volume rendering for a while, and I have my bounding box here, and I add slice. So no, not exact slice, slice is almost the same like auto slide, but just slice. So I go to exact direction like this. So you can see the slide now, it aligned to the bounding box of the chocolate bar. I can also change to orthographic view like this to see if you align perfectly. It's like this, right? Yep. And in the slide property board, we have rotation. This option to rotate object. You click on it, rotate once. You can see the trackball start to appear, and you can use this interact tool to start to tilt it. So I maybe tilt it this way. Maybe too much. Okay, like this easier. So I go here and then tilt them like this. Now you can see that I start to tilt the chocolate bar axis to this one. And previously we have chocolate bar that have axis not tilted. So maybe like this, you can see. Maybe I tilt it a bit more to give you the effect of the tilting axis. So still I need to turn around a bit. Yeah. Yeah, I tilted this way. And then when I overlay chocolate bar into, you can see now, I put the slide and I tilt to the axis that I want. For example, supposedly this chocolate bar is not aligned. So you want to align this chocolate bar new axis to align with this slide that I created. I want to have it aligned like this. So I create the slide and then make the angle that I want to align here. And then you just attach resample transform image again that we did before. Resample transform image. And here you can also select reference of resample transform image by click on the little white box. You will see reference attached to slides. And that's it. And then you can also choose option to crop or extended. I'll show you both. So maybe first try with crop. And crop, that's padding value 0. So they just not fill in the gap. So with the padding value of 0. And now if you look at the new volume, it looks like this. Because it tried to align the principal axis of the new chocolate bar and it's cropped. And you can also look at the new bounding box of this crop data. Like this one, maybe change color to green. So you can see that now is the warring green, let's say. So this is new object. You can see that it aligned based on the slide, because before it was here, but the volume rendering again. Before it was aligned to the orange object, orange bounding box like this, remember? And now when you set the new slide, so now the way they align is aligned to the green bounding box. And if you change from crop to extended, gonna look like this one. This one, and then you can see the bounding box like this. So you can see that the original object is aligned to the orange bounding box, but the new object will align to the green bounding box according to the slice. So if I remove this, you can see now is aligned according to the slide. So the object look tilted because I changed the center axis is aligned to the side. But you can see the slide is parallel to the new bounding box, but it also changed according to what we have. If you look at the older bounding box, the orange one, you can see the new bounding box is been, yeah. I hope this is clear with the digitization, transformation, reasonable transform images. So I think that is for now for today. Yeah, still have a lot of time for questions, and if you have anything, then we can also discuss as well.
I just ask
about the animation. So give me 10 minutes about animation is really pretty easy. Sorry, like I totally didn't look the full program. So yeah, so animation. Sorry for this. So I will just open the chocolate bar again for create animation. So there are two types of animation that you can creating. The first one is really easy. It's called rotation only. So to do that, you just load the dataset like chocolate bar. And what you're going to do, you can capture this motion, like rotation of objects, zoom in, zoom out. So to do that, you just need to add camera path by right-click somewhere in empty space and create object and select camera path here and create. And now you have this camera path appear here. To start recording or add keyframe to camera path, just have to select on this camera icon here. So it's the camera path editor. And you can see that they have this small window pop up. You can move it aside. The first thing we do is just to add keyframe. So keyframe, and then you start to rotate them. And then you add another keyframe, and you can see that the part of camera start to turn around. So it's more like you hold the camera and go around the object, zoom in, zoom out. So the same thing, I add another keyframe and maybe zoom in here. That keyframe. You can do this as much as you want. How many keyframe you want? Like this. Okay. And then maybe here. That should be enough. So once you finish your keyframe of this rotation, you just close this window or you click this one more time. You have enough keyframe, and then you go to the camera path properties and you just click play. You can have this object animated, and then you can save this as a movie. So to export this as movie, so you can go to camera path and right click, select movie maker and create it. In this movie maker, so you can do a lot of settings. You need to create file name, let's say on desktop, let's say one, and you can just select file format and size or viewer resolution, maybe here, and you can also even define custom resolution. You have it really high and so far. So I just do really quickly, and you can change like format, AVI movie, MPEG, JPEG movie, TIFF movie, and also you can see this all the parameter. Click apply, and then you start to record the movie. And in a few seconds, you should get your movie ready. So this is just very easily to do the movie using camera path. So you just rotate them around to see zoom in, zoom out. And the next one will be a bit more complicated, but I also have all the instruction in the slide that I'm gonna send to you. So don't worry. Just wait 1-2 seconds. So now I'm ready with the animation. Maybe just take a look at the results. This one. You can see, yeah, that's what you created. I also have something really easy to create as well. It's called camera orbit. This one, you go to like somewhere, right click, create object, camera orbit. And it is really simple because it's just to start to like rotate, really easy, but you don't need it. So camera path is more sophisticated. Here you just capture the orbit of the camera on the object. So I just camera orbit anyway. So since we have camera path and we already create keyframe in camera path, you can see here you can move around the keyframe from 0 to 90 keyframe. So the next part is animation workroom. So it's here. You have to go to animation workroom. So we're gonna import this keyframe from the camera path into this animation workroom. So once you click on the animation workroom, you see that they will have this stopwatch sign appear in front of each port. So any port that have this stopwatch sign, that you can export this value into the animation director. So what I can do right now, I want to import that time value here of the camera path into animation director. So click on time value, and now you can see that the camera path time value of the camera path from project view imported into animation director here. So what you can do, because it starts from timeline bar at 00, how we do by move this timeline bar, let's say to maybe 3 seconds, and then you click the keyframe maybe about 30, like this, 30, and then you click add keyframe. Again, do the same thing. I move to the 6 second to keyframe 60, add time value, and let's say go to maybe 9 seconds, the last one, and move to the last keyframe, 90, add keyframe. And you can see if you move back the timeline bar here and start to play, they'll import this movie animation coming up here. And you can see if you just don't define the stop of the movie, they will keep running until this here. So you need to define where you want to stop your movie. Otherwise, you're going to keep running. So next step is you want to add something else like translation of the auto slide or clipping plane. So what you could do is here, I go back in this here, and I will add clipping plane. Clipping plane. With clipping plane, clip once. Here, maybe like this, and you can move it to full volume like this, and then hide the clipping plane like this, but you can still translate them. You can see here. Okay, so the next step, I will also import this translation port of the clipping plane into animation director, and this you can do many things, so on and so on. You create surface, you create auto slide, you can always import the animation port that have stopwatch sign in front of it. So now we're going to do this by add the translation port into animation director. So make sure you start from 0 or any time you want to start. So I want to start from 0. So, and you can see the timeline bar, the translation bar, I move to 100%. So now it's ready. I click once on the stopwatch sign, and you can see down the clipping pane, the translate port is being added at the time 0 on animation director. Again, I move it to, let's say, not even maybe 5. So at time 5 seconds, I translate to, let's say, 40% like this. And then again, add keyframe. And then I move to, let's say, maybe 7 seconds and move to 28% at keyframe. And when I move back to time 9, then you translate back to 100% again, add keyframe like this. And then finish. Then you can move the timeline bar back to the beginning, and you can see your results here. Yeah. And you can see that in the timeline bar, you can always change, adjust your length, or you can, for example, how you can start to extend, and also to see the interpolate of the movie. It could be linear or inward, something like so. You can see the different option, and then you can see that it's gonna be slower because of the time that you are increasing or reducing. So this is some option, and this you can apply to every port that have this stopwatch sign to add it into this movie. I can see the slower, and okay, and then I define maybe here. Yeah, so when you have everything ready, all the combination, but also it needs a lot of planning, because if you want to do many animation, like first from 2D slide, and then this 2D slide appear, disappear, and then appear with 3D volume, you have to plan a bit before you do this animation, what to come first, what next, and in which step. So, and then after that, when you finish with the movie keyframe, you just click on this movie creation, and again you get to select quality, encode, and frame rate, how many frames you want to add it, and maybe like 200, reduce the frame rate, and then increase the reduce the frame and increase the frame rate and the quality, and also let's say 300p, and create movie. No, I have to select folder where I want to save movie. Strange. Yeah, so I have to select, yeah, new animation, save, and create movie. And then I start to have this movie. It's created. Maybe show you quickly on the slide while we're waiting. So if I will send this at the end of the workshop I think we have it here as well, this landmark registration. Yeah, so we have this animation. So you can go to how you create and explaining things step. So don't worry, so you have all the information. Okay. And thing is ready, and then just take a look. Last one. So you can see that very fast and getting slow because of the keyframe that you are adjusted at the end. You can also change the background as well. Usually, if you want to create nice animation, maybe you can go here, view background, and use the uniform color and change to, let's say, white, or you can change to view background and gradient and select more like as you like. Yeah. I hope this just need to practice a little bit and then a bit of planning before you. Yeah. But also you can also reach out to me if you have any further question on this topic. Okay. Thank you again.